What if the deepest silence in the universe is a lie? We imagine space as the ultimate emptiness, a realm of serene, majestic quiet where celestial bodies trace their silent clockwork paths across eternity. We see a tapestry of stars unchanging and remote, a portrait of cosmic peace. For all of human history, this has been our comforting assumption, a story we told ourselves while huddled around ancient fires, gazing up into the fathomless dark. But this tranquility is an illusion, a magnificent deception painted across a canvas of unimaginable violence. Because what you're looking at is not a portrait, it is a crime scene, and it is happening right now, unfolding on a scale so vast that its true nature has remained hidden from us until this very moment. Your home, the Milky Way, is a spiral of impossible beauty, a city of 400 billion stars, a swirling disk of light and dust, 100,000 light-years across. From our tiny vantage point nestled deep within one of its graceful arms, we see it as a gentle, nurturing cradle. It is the architect of our sun, the source of the elements in our blood, the grand celestial island we call our own. Yet this perception too is incomplete. Pulling back far beyond the familiar glow of its central bulge and the filigree of its spiral arms, a different story begins to emerge from the darkness. Out here in the galactic halo, a vast and sparsely populated wilderness, we discover something haunting. Ghostly ribbons of light, faint and ethereal, wrap themselves around our galaxy like shimmering silk. These are not nebulae. They are not random clusters of cosmic dust. They are scars. They are the luminous spectral remains of entire worlds, star systems torn asunder, their integrity shattered by a force of unimaginable power. For millennia, they were invisible to us, their faint glow lost in the overwhelming brilliance of the Milky Way's core. But with new eyes, new technologies capable of charting the precise motion and chemistry of billions of individual stars, we can finally read the evidence. And the evidence tells an unambiguous, chilling tale. These ethereal streams are the last dying breaths of other smaller galaxies. They are celestial breadcrumbs leading us to a shocking conclusion. Our home, the beautiful life-giving Milky Way, is a predator. A cannibal whose serene appearance belies a voracious, insatiable appetite. This is not a story of the ancient past, a fossilized record of some long-forgotten cosmic cataclysm. This process, this act of galactic cannibalism, is a live event. We are witnesses, and more than witnesses, we are residents living deep within the belly of the beast. The grand spiraling structure we inhabit was not born this way. It was built. It was assembled over billions of years, piece by bloody piece, through the systematic consumption and assimilation of its neighbours. Our galaxy is a monolithic empire founded on conquest, and the ghostly trails in its halo are the forgotten banners of the vanquished. They are the incandescent tears shed by star nations that strayed too close, caught in a gravitational snare from which there is no escape. Each star in these streams was once part of a cohesive whole, a proud, independent galaxy, with its own history, its own centre, its own destiny. Now they are nothing more than refugees, their homes dismantled, their orbits warped, their collective identity dissolved into the colossal structure of their conqueror. Look closer at one particular stream, the most prominent and dramatic of them all. It is a river of stars known as the Sagittarius Stream, and it wraps around the Milky Way in a vast looping polar orbit. This is not an ancient relic. This is the scene of the active crime. At the head of this spectacular trail of stellar debris, we find the culprit's current victim, the Sagittarius Dwarf Spheroidal Galaxy. A mere 50,000 light-years from the galactic core, this small galaxy is locked in a mortal struggle with our own. It was once a self-contained island of perhaps a few billion stars, a miniature version of the Milky Way orbiting us from a respectful distance. But its orbit decayed. With each pass, it plunged deeper into the Milky Way's gravitational well, a cosmic whirlpool from which it could never recover. Imagine a ship caught in a maelstrom. On its first pass, it loses a few planks. On the next, its mast is torn away. With each successive agonizing loop, it is ripped apart more completely, its structure compromised, its crew scattered into the churning waters. This is the fate of the Sagittarius Dwarf. The immense tidal forces of the Milky Way, a gravitational power hundreds of times greater than its own, are stretching it, pulling it like cosmic taffy. Stars on the near side are pulled harder than stars on the far side, and this differential force has become a celestial torture rack. It is being unravelled star by star. Entire clusters are siphoned away, forming the long leading and trailing tails of the stream we now observe. Its dark matter halo, the invisible gravitational scaffolding that once held it together, has been almost entirely stripped away, leaving its stellar heart exposed and vulnerable. We are watching the dismemberment of a galaxy in slow motion. The process takes hundreds of millions of years, a timescale that feels eternal to us, but is a fleeting moment in the life of the cosmos. For the Sagittarius dwarf, the end is already written. Its remaining core will make a few more fatal passes before it has fully disrupted its last stars, flung out to join their brethren in the stream. And then, over the next billion years, even that stream will fade. The orbital paths of its individual stars will slowly smear out, mingling and mixing with the native stars of the Milky Way's halo, until all evidence of a separate identity is gone. They will be assimilated. They will become part of us. Future alien astronomers looking at our galaxy in a distant epoch will see no stream at all. They will only see a slightly larger, slightly more populous Milky Way, unaware that billions of its citizens are immigrants from a world that was systematically devoured. This is a profoundly unsettling revelation. To learn that the foundation of our existence is built upon the ruins of others forces us to reconsider our place in the universe. We are not living in a placid cosmic garden. We are living inside a dynamic, violent and ever-changing ecosystem, where the big eat the small. And the Sagittarius dwarf is not the first. By analysing the chemical compositions, ages and trajectories of stars within our galaxy, astronomers have become cosmic archaeologists. They have uncovered the bones of other victims buried deep within the Milky Way. There is the Gaia-Enceladus sausage, the remains of a fairly massive galaxy, consumed about 10 billion years ago. An event so violent it puffed up our galaxy's halo and set the thick disk of our inner galaxy ringing like a bell. Its stars with their distinct chemical fingerprints and elongated sausage-shaped orbits still haunt our galactic neighbourhood. There are other smaller ghosts as well. The Helmi stream Cetus and numerous other stellar currents, each one a testament to another long-dead galaxy, another conquest in the Milky Way's relentless campaign of expansion. Our home is a composite entity, a Frankenstein's monster of galactic proportions stitched together from the dismembered corpses of at least a dozen smaller galaxies, and likely many more. The very ground beneath our cosmic feet is a graveyard, and this process is fundamental to how the universe works. Galaxies are not static islands of light. They are the primary agents of cosmic evolution, constantly interacting, merging and consuming one another, in a gravitational dance that has played out since the dawn of time. This celestial cannibalism is not an aberration, it is the norm. It is the primary engine of galactic growth, the force that transforms small primitive galaxies into the grand, majestic spirals and giant ellipticals we see today. Without these acts of consumption, the Milky Way would be a shadow of its current self. These captured stars, and more importantly the vast reservoirs of a gas and dark matter that came with them, provided the raw material for new generations of star formation. The shocks from these collisions may have compressed gas clouds within our own disk, triggering bursts of stellar birth, perhaps even contributing to the conditions that eventually formed our own sun and solar system. It's a staggering thought. The death of one galaxy, the obliteration of another world, may have been a necessary precondition for our own existence. Creation and destruction locked in an inseparable cosmic embrace. We are the children of a cannibal, born from the very violence that seems so terrifying. This discovery forces us to confront a series of profound questions that strike at the heart of our understanding of the cosmos. If galaxies are built through consumption, what does this tell us about the very first galaxies, the pioneers that emerged from the cosmic dark ages? How did they grow from tiny seeds into the leviathans that now dominate the universe? Is this a story of gradual accumulation, or of violent transformative mergers that completely reshape the participants? And what role does the invisible universe, the enigmatic dark matter that constitutes the vast majority of a galaxy's mass, play in this drama? It is the gravitational puppeteer, the unseen force orchestrating this entire cosmic ballet of life and death. Yet, we know almost nothing about it. These stellar streams The leftovers from these cosmic feasts may be our best clues, offering a way to map the shape of the dark matter halo and test our theories of its nature. This ongoing act of cannibalism is not just a window into the past, it is a preview of our own future. The Milky Way, for all its predatory prowess, is not the biggest fish in our local cosmic pond. On a collision course with us hurtling through the intergalactic void at over 100 kilometers per second is a far grander entity, the Andromeda Galaxy. It is our bigger sibling, a galaxy with perhaps 1 trillion stars and its own long brutal history of consuming its neighbours. In about 4.5 billion years, our two galaxies will meet. The cannibal will become the meal, or perhaps both will be subsumed into an entirely new colossal entity. What will that encounter look like? It will be a merger on a scale we can barely comprehend, a process that will tear both galaxies apart and remake them into something new. The sky, as seen from Earth, should any Earth still exist, will be transformed into a terrifying, beautiful spectacle of cosmic firestorms and stellar chaos. So we are left standing on a precipice of understanding. We have discovered that we live inside a predator, a celestial empire built on the wreckage of its neighbours, a process that is still happening before our very eyes. We see its past written in the ghostly scars that encircle us. We see its present in the slow-motion murder of the Sagittarius Dwarf, and we see its future in the inexorable approach of Andromeda. This violent, beautiful, and terrifying reality forces us to ask the ultimate question. What is the true meaning of this endless cycle? Is the universe a place of creation or destruction? Or are they simply two sides of the same cosmic coin, an inseparable duality, where the death of one world is the necessary price for the birth of another? To find the answers, we must delve deeper into this crime scene. We must follow the evidence from the faintest stellar streams to the hearts of the most violent galactic collisions on a journey to understand the birth, the life, and the ultimate spectacular fate of our galactic home. The silence we imagine in space is a profound illusion, a misconception born from our terrestrial experience. Out there in the vast velvet darkness between the stars, the universe is not quiet. It is not still. It is a place of unimaginable violence and breathtaking creation, a symphony of gravitational forces playing out on scales that defy our comprehension. Forged in the aftermath of the Big Bang, the first stars were born from primordial hydrogen and helium, coalescing into vast, brilliant clouds. But these stars were not destined for solitude. Gravity, the quiet, persistent architect of the cosmos, began to weave them together, pulling them into the first true cosmic structures, the first cities of light. We call them galaxies. To us they appear as serene, majestic islands of light captured in photographs, as static spirals and glowing ellipses frozen in time, 100 billion stars like our own sun spinning in a celestial pinwheel. 1 trillion suns packed into a radiant incandescent sphere. These are the fundamental building blocks of the universe, the grand repositories of matter, of planets, of life, and of potential. Yet this island portrait, this vision of galaxies as isolated, self-contained empires, is a dangerously incomplete picture. To truly understand what a galaxy is, you must first understand the environment it inhabits. You must zoom out far beyond the confines of a single spiral arm, past the glow of the central bulge until the galaxy itself shrinks to a mere pinprick of light. Keep going. Pull back until you can see 1,000, 1,000,000, 1,000,000,000 galaxies at once. What you would witness is not a random scattering of points like dust motes in a sunbeam. Instead, you would see a structure of impossible grandeur, a luminous and intricate network that permeates all of creation. We call it the cosmic web. It is the largest known structure in the universe, a gargantuan tapestry, woven from threads of dark matter and intergalactic gas. These filaments, some stretching for hundreds of millions of light years, are the superhighways of the cosmos, channeling matter and energy from the empty voids into dense, brilliant intersections. And at these intersections, where the filaments knot together like the junctions of a neural network, galaxies are born and galaxies thrive. They are not islands at all. They are shimmering beads of dew clinging to the strands of an infinite invisible web. This cosmic framework dictates their very existence, feeding them with a slow, steady stream of pristine gas to fuel the birth of new stars. but it also binds them together, ensuring their paths will inevitably cross. Within this grand architecture, galaxies are neighbours subject to the constant, inescapable pull of each other's gravity. They are destined to interact, to dance, to collide, and as we will see, to consume one another in a process as ancient and as fundamental as the universe itself. To grasp how this happens, we must re-examine our own home, the Milky Way, and confront the ghost that lives within it. What you see of our galaxy, the breathtaking river of light that spills across the night sky, is merely the brilliant facade. It is the glittering skyline of a metropolis whose true size is hidden in darkness. The familiar disk with its graceful spiral arms is where the majority of star formation happens, where nebulae glow with the light of celestial nurseries, and where we make our home. This vibrant active region spans a colossal 100,000 light years. But it's not the galaxy. Not really. It is just the most visible part. The true galaxy is something far larger, far more mysterious, and vastly more massive. Surrounding the luminous disk, extending far out into the blackness of intergalactic space, is an enormous spherical cloud. We call it the galactic halo. For decades it was thought to be a sparse ethereal sphere containing a few scattered ancient stars, the oldest residents of our galaxy and globular clusters, tight spherical swarms of stars orbiting the galactic centre like ancient satellites. We pictured it as a quiet, forgotten attic, a celestial graveyard of stars that time had left behind. But this picture was profoundly fundamentally wrong. The halo is not empty. It is in fact the most massive and gravitationally dominant component of our entire galaxy. It is just invisible. This revelation began not with a grand discovery, but with a persistent nagging anomaly. In the 1970s, astronomers studying the rotation of spiral galaxies, much like our own, noticed something that defied the laws of physics as we knew them. They expected that stars on the outer edges of a galaxy's disk far from the gravitational centre would move more slowly, just as Neptune orbits our Sun far more slowly than Mercury. It's a basic principle of gravity: the farther you are from the central mass, the weaker its pull and the slower your orbital speed. But that is not what they found. Instead, the stars on the very fringes of these galaxies were moving at incredibly high speeds, racing along as fast or even faster than stars much closer to the centre. There was no logical reason for it. A galaxy spinning this fast with only the mass of its visible stars, gas and dust, to hold it together should have torn itself apart billions of years ago. The stars on the edge should have been flung out into the void like water from a spinning wheel. The only way they could be held in their orbits, the only way the galaxy could remain intact, was if there was more mass. A lot more mass. A staggering amount of unseen, undetectable matter exerting a powerful gravitational grip. This missing mass wasn't in the disk or the central bulge. It had to be distributed throughout that vast spherical halo, forming an immense invisible scaffolding that cradles the entire visible galaxy within it. We call it dark matter. It is a substance that does not emit, reflect, or interact with light in any way. It is a ghost made of gravity. We cannot see it. We cannot touch it. We only know it is there because we can feel its immense gravitational presence, warping space-time, bending the path of distant starlight, and most importantly holding our galaxy together. This dark matter halo is the true cosmic anchor of the Milky Way. It outweighs all the stars, all the planets, all the gas and dust by a factor of nearly 10 to 1. Our luminous spiral city is just a small, brilliant settlement, built within the centre of a colossal invisible continent, and this changes everything. This enormous gravitational ghost is not a static cage. It is a dynamic, powerful web. Its gravitational influence extends far beyond the visible edge of our galaxy, a sphere of influence stretching over 1,000,000 light-years in every direction. It is the ultimate celestial snare. Any smaller object, any dwarf galaxy that wanders too close, doesn't just feel the pull of the Milky Way's stars. It feels the inescapable, overwhelming grip of this vast unseen halo. Once caught, there is no escape. The smaller galaxy becomes a satellite bound in a long decaying orbit destined to be slowly reeled in, stripped apart, and ultimately consumed. This is the fundamental mechanism of galactic cannibalism. It is not a battle of stars against stars, but a gravitational mismatch of epic proportions a tiny visible galaxy caught in the web of an invisible giant. For most of human history, this brutal dynamic reality of the cosmos was utterly hidden from us. Our understanding of galaxies was for a long time defined by their appearance, by their majestic and seemingly permanent forms. When Edwin Hubble first proved that the faint fuzzy nebulae in our sky were in fact distant island universes, he set about trying to classify them. The result was a famous diagram known as the Hubble tuning fork. On one side were the smooth, featureless elliptical galaxies. On the other, the elegant spiral galaxies further divided into those with a central bar and those without. He believed this diagram represented an evolutionary sequence that galaxies were born as one type and slowly peacefully transformed into another over billions of years of isolated evolution. It was a neat, orderly and beautifully simple picture. It portrayed a universe of quiet, parallel lives, where each galaxy was a self-contained system, evolving on its own terms, undisturbed by its neighbours. This view dominated cosmology for half a century. It was an age of cosmic peace, a belief that the grand structures of the universe once formed were largely immutable and fixed. But the universe, as we would learn, is anything but neat and orderly. It is messy, chaotic, and relentlessly violent. The first cracks in this peaceful facade came from observations that simply didn't fit the model. In the 1960s, the astronomer Halton Arp, a maverick and a contrarian, compiled a catalogue that would become legendary, the Atlas of Peculiar Galaxies. While his contemporaries focused on the perfect spirals and serene ellipticals that fit neatly into Hubble's scheme, Arp was fascinated by the oddballs, the misfits, the cosmic train wrecks. His atlas was a gallery of galactic grotesques. There were galaxies that looked like they were being torn apart, with long, ghostly streamers of stars called tidal tails stretching out for hundreds of thousands of light years into the void. There were galaxies connected by delicate glowing bridges of gas and dust, as if they were reaching out to one another. There were galaxies with shattered, distorted cores, their spiral arms mangled and misshapen, looking less like pinwheels and more like the aftermath of a catastrophic explosion. For the mainstream astronomical community, these were mere curiosities, rare exceptions to the rule of orderly galactic evolution. They were dismissed as photographic flukes, or strange unexplained phenomena that didn't challenge the fundamental paradigm. But Arp insisted they were something more. He believed he was seeing evidence of galaxies interacting, colliding and merging. He was seeing the cosmic violence that the clean, elegant theories had ignored. He was right, but he was ahead of his time. The evidence was compelling, but it was circumstantial. To prove that these bizarre shapes were the direct result of galactic collisions, science needed a new tool, one powerful enough to rewind cosmic time and watch these cataclysms unfold. That tool arrived with the dawn of the computer age. In the early 1970s, two astronomers, Alaa and Juri Tumri, pioneered a revolutionary new approach. They created digital universes in a box. Using the most powerful computers of their day, they wrote programs that could simulate the gravitational interactions between two massive galaxies over hundreds of millions of years. For the first time, we could play God, setting two virtual spiral galaxies on a collision course and watching what happened as the inexorable laws of gravity took over. The results were a stunning vindication of Arp's work. As the simulated galaxies approached each other, their mutual gravity began to warp their beautiful symmetric disks. The computers showed how vast tendrils of stars and gas could be flung out into space, forming the exact same long, graceful tidal tails that Arp had photographed. They showed how bridges of matter could form between the two interacting systems. As the galaxies passed through each other, their structures were shredded, their spiral arms tangled, their cores thrown into disarray. The simulations produced with astonishing fidelity the entire zoo of peculiar shapes from Arp's atlas. What had once been dismissed as peculiar was now revealed to be the predictable, inevitable outcome of a gravitational dance. This was the smoking gun. The theory of isolated, peaceful galaxies was dead. The Tumri brothers' work sparked a revolution in our understanding of the cosmos. Astronomers began to look at the universe with new eyes, actively searching for evidence of interactions and mergers, and they found it everywhere. We now understand that these collisions are not rare anomalies. They are the primary engine of cosmic evolution. The largest galaxies in the universe, The giant ellipticals that sit at the heart of massive clusters are not born that way. They are cosmic cannibals, galactic empires, built from the wreckage of hundreds, even thousands of smaller galaxies they have consumed over billions of years. Their immense size is a testament to their violent history. Even the beautiful spiral galaxies like our own are not pristine primordial structures. Their thick disks, their central bulges, and their vast star-dusted halos are built up over cosmic time through a relentless series of mergers with smaller dwarf galaxies. Each collision adds new stars, infuses new gas to fuel another generation of starbirth, and contributes to the ever-growing mass of the dark matter halo. Growth for a galaxy is not a gentle internal process. It is a brutal act of acquisition. It is a story written in gravitational tides in stellar streams, and in the ghostly remnants of devoured worlds. The evidence was undeniable, and the implications were staggering. For this cosmic cannibalism, this dance of destruction and creation, was not some distant abstract phenomenon occurring in far-flung corners of the universe. It was and is the primary engine of our own galaxy's becoming. The Milky Way, our serene river of light, is a predator. And its hunt is not a relic of the distant past. It is happening right now in our own cosmic backyard, and we have a front-row seat to the kill. So where do we find the evidence for this cosmic violence, this silent gravitational predation that defines a galaxy's life? Where are the smoking guns, the celestial crime scenes that prove our Milky Way is not a serene island, but an empire built on conquest? The answer, it turns out, is all around us. It is written in the very architecture of our galactic home, woven into the fabric of the night sky itself. For decades we believed our galaxy was a static, majestic pinwheel, evolving in quiet isolation. But to see the truth, we had to learn to look not for what was there, but for the subtle patterns of what shouldn't be, for the ghosts of victims, long since departed. We had to learn to read the scars. Our search for these scars begins not in the distant universe, but right here in our own backyard. And it begins with a mystery that unfolded in the 1990s, an accidental discovery that would shatter our peaceful image of the Milky Way forever. Astronomers Rodrigo Ibata, Gerard Gilmore and Mike Irwin were not hunting for cannibals. They were conducting a meticulous survey of stars in the galactic bulge, that dense glowing heart of our galaxy, and extending their gaze towards the halo, the sparse spherical region enveloping it all. They were cartographers painstakingly charting the stellar populations of our home. Using the Anglo-Australian telescope, they were measuring the velocities of stars, trying to understand the complex dance of orbits at our galaxy's core. But as they sifted through their data, they found something deeply unsettling, an anomaly that defied all conventional models. There was a small, tight group of stars, a faint smudge in the constellation of Sagittarius, that was moving together. That in itself was not unusual. Globular clusters and open clusters dot our galaxy. The problem was their velocity. They were moving in a way that made no sense. They weren't orbiting with the rest of the galaxy. They seemed to be on a collision course, plunging through the disk from a peculiar angle. It was as if a school of fish were suddenly found swimming straight through a whirlpool, utterly ignoring its powerful currents. This was more than just a cluster. It was a coherent system, a tiny galaxy in its own right, hiding in plain sight behind the dazzling curtain of the Milky Way's central stars. They had stumbled upon the Sagittarius Dwarf Spheroidal Galaxy, a satellite galaxy caught in the act of being consumed. Imagine you are standing on a shoreline watching a powerful current tear a small boat apart. At first you see the boat itself struggling against the tide. Then you begin to notice the debris. A plank here, a sail there, a trail of flotsam stretching out for miles, marking the path of its destruction. This is precisely what astronomers began to see when they looked closer at Sagittarius. The initial discovery was just the core, the still intact heart of the doomed galaxy. The real revelation came when we started to find its debris, the stars torn from its body by the Milky Way's immense gravitational tides. This is where the detective story truly begins, moving from finding the victim to tracing the entire horrifying extent of the crime scene. To do this required a new kind of astronomy, a brute force approach to mapping the cosmos. Projects like the Sloan Digital Sky Survey, or SDSS, were revolutionary. Instead of pointing a telescope at one specific object of interest, SDSS did something far more ambitious. It aimed to create a deep, three-dimensional map of a huge swathe of the universe. For years, it scanned the sky night after night, capturing images and data for hundreds of millions of celestial objects. It was a cosmic census on an unprecedented scale. And buried within this mountain of data were the clues astronomers needed. They could now sift through the positions, colours and brightnesses of countless stars looking for the telltale breadcrumbs left by Sagittarius. The technique they used, called stellar photometry, is conceptually simple but powerful. Stars within a single galaxy or cluster tend to be born from the same cloud of gas and dust at roughly the same time. This shared heritage gives them a distinct chemical fingerprint and a predictable evolutionary path. When plotted on a colour magnitude diagram which compares their brightness to their colour, they fall along a clear characteristic sequence. The astronomers knew what the main sequence of stars from the Sagittarius dwarf should look like. Their task was to hunt for that specific pattern among the billions of other stars in the Milky Way's field of view. It was like searching a vast sandy beach for grains of sand that all came from a single unique mountain. What they found was staggering. It exceeded every prediction. Extending from the core of the Sagittarius dwarf were two colossal sweeping arms of stars wrapping around the entire Milky Way like a celestial serpent. One stream of stellar wreckage arcs over the North Galactic Pole while its counterpart streams below the south. We call them tidal streams, but that term feels far too gentle for the violence it represents. These are not gentle rivers of stars. They are the dismembered limbs of a galaxy stretched and torn across 100,000 light-years. Each point of light in that stream is a sun, an orphaned star stolen from its home, now bound to an eternal ghostly procession around its conqueror. You are looking at the spectral remains of a world, a gravitational ghost haunting our skies. For the first time we could see the full scale of this ongoing cannibalism. The Sagittarius dwarf has likely orbited the Milky Way several times over billions of years, and with each pass our galaxy's gravity has flayed another layer of stars and gas from its body, like a celestial blowtorch stripping away its substance. The streams we see today are the accumulated ruins of those brutal encounters. They are a testament to a battle that has raged for eons and is still not over. The core of the galaxy, a tightly bound knot of a few million stars, continues its slow death spiral, destined to merge completely with the Milky Way's heart in perhaps another 100 million years. We are witnessing in real time the final throes of a galactic execution. These streams are more than just a grisly spectacle. They are a profound scientific tool. Because they wrap so completely around our galaxy, they act as a tracer, a form of cosmic dye injected into the system. By studying the precise path and velocity of these stellar streams, we can map the gravitational field of the Milky Way with astonishing precision. And this has led to one of the most fundamental discoveries about our own home. The streams do not move as they should if the only gravity at play was from the stars and gas we can see. Their orbits are shaped and guided by something vast, unseen, and overwhelming. They are tracing the true shape of the Milky Way's dark matter halo. The ghost of a dead galaxy is allowing us to weigh the invisible substance that holds our own galaxy together. The victim in its final moments is revealing the true nature of its killer, but photometry, the mapping of positions and brightness, only gives us part of the picture. It tells us where the stars are, but not what they truly are or how they are moving in 3 dimensions. To confirm that this river of suns really was a single coherent structure torn from an invading galaxy, we needed another tool, spectroscopy. If photometry is like taking a photograph of a crowd, spectroscopy is like isolating every single person and listening to their unique voice. By capturing the light from a star and passing it through a prism or grating, astronomers can spread it out into its constituent colours, a rainbow spectrum. Imprinted on this spectrum are dark lines, absorption lines, which are like a unique chemical barcode. Each element, hydrogen, helium ion, oxygen, absorbs light at specific well-known wavelengths. By analysing these lines, we can determine a star's chemical composition with incredible accuracy. When we pointed our spectrographs at the stars within the Sagittarius stream, we found their barcodes were different. They were systematically poorer in heavy elements, or metals, as astronomers call them, compared to the majority of stars in the Milky Way's disk. They were unequivocally foreigners. Their chemistry screamed that they were born in a different environment, a smaller, less chemically evolved galaxy. This was the DNA evidence that linked all the stars in the stream back to a single parent, the Sagittarius Dwarf. Spectroscopy delivers a second crucial piece of information: velocity. Due to the Doppler effect, light from an object moving towards us is shifted to the blue end of the spectrum, while light from an object moving away is shifted to the red. By measuring this red shift or blue shift with high precision, we can calculate how fast a star is moving along our line of sight. And when we did this for the Sagittarius stream, we found that all the stars across tens of thousands of light years were moving in concert. They shared a common motion, a kinematic signature that proved they were travelling together on this immense orbit. The case was closed. We had the location of the crime scene, the debris field, the chemical forensics, and the dynamic evidence of the escape path. The peaceful static model of our galaxy was dead. In its place was a dynamic, violent, and endlessly fascinating reality of a galaxy that grows by eating its neighbours. The discovery of the Sagittarius stream opened the floodgates. Once we knew what to look for, we started finding these ghostly rivers of stars everywhere. The sky, it turned out, is crisscrossed with the faint trails of devoured galaxies, a complex web of ancient tragedies. But Sagittarius is a current event, a meal still being digested. This raises an even more profound and difficult question. What about the meals that were finished long ago? How do you find the evidence of a collision that happened not millions but billions of years in the past? A murder where the body has been completely assimilated into the victor. The clues for such ancient crimes are far more subtle, buried deep within the very structure of the Milky Way's native star populations. To find them, we would need a new eye in the sky, a mission of such audacious precision it could track the movement of stars with the accuracy of measuring the width of a human hair from hundreds of miles away. We needed Gaia. Launched by the European Space Agency in 2013, the Gaia satellite is arguably the most ambitious cartography project in human history. Its singular purpose is to create the ultimate 3D map of our galaxy. For years, it has been scanning the sky, measuring the precise positions, parallaxes, and proper motions of nearly 2 billion stars. Parallax gives us distance, a crucial third dimension that ground-based surveys struggle to obtain on a massive scale. But the true revolution is in proper motion, the tiny, almost imperceptible movement of stars across our line of sight. By tracking these motions over time, Gaia creates a dynamic moving map. It can essentially play back the clock or fast-forward it, revealing the hidden orbital architecture of the galaxy. It is a cosmic time machine, and it has allowed us to uncover a ghost far larger and more consequential than Sagittarius. As astronomers began to sift through Gaia's extraordinary initial data releases, they noticed something peculiar, just as their predecessors had in the 1990s. There was a population of stars, many of them right in our solar neighbourhood, that were behaving very strangely. While most stars in the galactic disk, including our Sun, move in relatively flat circular orbits, this group was different. Their orbits were bizarrely elongated and sausage-shaped, plunging them high above the galactic plane and then deep down through it again. They were moving on radical eccentric paths like comets in the inner solar system, and when their velocities were plotted, they formed a distinct elongated clump, a shape, that quickly earned this ghost galaxy the nickname the Gaia Sausage. A more formal name was later proposed, Gaia-Enceladus, after the mythological giant who was buried under Mount Etna. It's a fitting name because this was no dwarf. This was a giant in its own right, a massive galaxy, perhaps 4 times the mass of Sagittarius, that collided with a young Milky Way some 10 billion years ago. Unlike the slow tidal stripping of Sagittarius, this was not a gentle nibble. This was a catastrophic head-on collision, a major merger event that fundamentally reshaped our galaxy in its infancy. The evidence wasn't in a neat, tidy stream because the merger was too old and too violent for that. The body of Gaia-Enceladus had been completely disrupted, its stars scattered and assimilated, their orbits randomized by the chaotic encounter. So how can we be sure they are invaders? Once again, the proof lies in their chemistry and their motion. Spectroscopic follow-up confirmed that these stars on sausage-shaped orbits share a distinct chemical signature different from the native Milky Way population. but Gaia provided the ultimate confirmation. By tracing their strange orbits backward in time, computer simulations showed they all originated from a single massive object that fell into the Milky Way billions of years ago. We are living amongst the debris of this colossal ancient wreck. Tens of thousands of the stars you can see with the naked eye are not native to our galaxy. They are immigrants, survivors of a lost cosmos, their wild orbits a permanent scar from the trauma of that ancient impact. This discovery was not just an astronomical curiosity, it solved a long-standing puzzle about the very structure of our galaxy. The Milky Way has two primary stellar disks. There's the thin disk, a dense flat plane where our sun resides and where most new stars are born. But surrounding it is a thick disk, a more diffuse puffy halo of older stars. For years no one could quite explain how this thick disk formed. The Gaia-Enceladus merger provided the answer. The collision was so violent that it would have acted like a stone thrown into a pond. The impact would have heated the existing young disk of the Milky Way, puffing it up, kicking its stars into more energetic, disordered orbits, creating the thick disk we see today. The very foundations of our galaxy were forged in this cataclysm. The invader didn't just add its stars to our own. Its violent death gave birth to a fundamental component of the Milky Way structure. So we have two starkly different examples of galactic cannibalism. One, a crime in progress, the other a cold case from the dawn of time. Sagittarius is being delicately dissected, its streams providing a pristine map of our galaxy's gravitational field. Gaia-Enceladus was a brutal transformative merger, its legacy not a tidy stream, but a chaotic churning of stars that redefined our galaxy's shape. Together they paint a new dynamic and violent portrait of galactic evolution. Our home is not a static object that has existed peacefully for eternity. It is a composite being, an amalgam of countless devoured systems, its structure a testament to its violent past. Every star with a strange orbit, every globular cluster with an unusual chemistry is a clue, a remnant of another lost world. The quiet beauty of the night sky is a deception. We are living inside the evidence, standing on the shoulders of galactic ghosts. And this raises an even more chilling question: if this is our past and our present, what does it tell us about our future? For the cosmic dance of cannibalism is far from over, and the next partner on our galaxy's dance card is far, far larger than any we have yet encountered, undefined. And so we watch Sagittarius die. We follow its spectral river of stars, a celestial ghost bleeding across our sky, and we feel like privileged witnesses to a rare and terrible cosmic event. For decades, this was the prevailing view, that our Milky Way was a largely serene island universe, and this ongoing merger was a dramatic but isolated incident, a singular scar on an otherwise placid history. We believed we were observing an anomaly, a fluke of gravitational chance unfolding in our own cosmic backyard. But what if we were wrong? What if the crime scene we are witnessing is not the only one? What if scattered all around us are the cold cases, the forgotten victims, the faint outlines of countless other slaughters stretching back to the dawn of time? This singular haunting revelation would not come from a telescope peering at distant galaxies, but from turning our most powerful instruments inward upon ourselves. It would force us to become galactic archaeologists, sifting through the dust and stars of our own home, not to find what we are, but to uncover the multitude of galaxies we once were. The evidence, it turns out, was hiding in plain sight, written in a language of motion and chemistry that we were only just beginning to decipher. To uncover these ancient acts of cannibalism, you can't simply look for the obvious wreckage. After 1 billion years, a dwarf galaxy isn't a distinct object anymore. It's a phantom, its essence smeared across tens of thousands of light years. You have to hunt for its ghost. You begin by looking at the stars, not just their brightness or their colour, but their motion. Think of our galaxy not as a static painting, but as a swirling three-dimensional metropolis of 400 billion stars each, with its own trajectory, its own unique velocity through space. Most stars born and raised in the Milky Way follow the prevailing traffic, orbiting in a relatively flat, orderly plane we call the thin disk. But the stars from an alien galaxy, one that fell in from a completely different angle, would betray their origins. They would retain a memory of their former life, moving together in a coherent stream cutting across the normal flow of traffic, like a rogue current in a vast ocean. They travel on tilted eccentric or even retrograde orbits, a telltale signature of an outsider that was violently thrown into the mix. This is precisely what our latest celestial cartographers, like the Gaia Space Observatory, have been built to do. By measuring the precise positions and velocities of over 1 billion stars, Gaia has created the most detailed map of our galaxy ever conceived. And within this staggering dataset, the ghosts began to emerge from the static. We found not just the Sagittarius stream, but others. The Orphan stream, a faint, lonely thread of stars with no known parent. The Cetus polar stream wrapping around the Milky Way at a bizarre 90-degree angle to the main disk. Dozens of stellar rivers, each one a tombstone marking a galaxy that once was. But motion alone is not enough to secure a conviction. To truly link these streams to their devoured progenitors, we needed a form of cosmic DNA testing. We needed to analyze their chemical composition. Every star carries the chemical fingerprint of the gas cloud from which it was born. A small primitive dwarf galaxy has a different chemical history than a large complex spiral like our own. It will have fewer heavy elements, what astronomers call metals, because it has had fewer generations of stars to forge them in their nuclear hearts. By analysing the light from the stars in these streams, we can read their chemical barcodes. And when we find a group of stars all moving together on a strange orbit that also share the exact same uniquely primitive chemical signature, we have found it. We have found the irrefutable proof of a murdered galaxy. The most profound of these discoveries was a colossal ghost hiding within the Milky Way's own halo, a structure so vast it has been posthumously named Gaia-Enceladus. It wasn't a thin stream, but a huge diffuse population of stars on bizarre sausage-shaped orbits, all sharing the same chemical DNA. The data told a shocking story. About 10 billion years ago, a dwarf galaxy of considerable size, perhaps a tenth, the mass of the entire Milky Way at that time, slammed into our young galaxy. This was no glancing blow, it was a cataclysm. The collision was so violent that it didn't just leave a stream, it puffed up our galaxy's entire inner structure, kicking native Milky Way stars onto higher, wilder orbits, and creating what we now call the thick disk, a puffy, older, more chaotic layer of stars that surrounds the younger, flatter thin disk where our own sun resides. You live inside the evidence of this ancient crash. Many of the stars you see in the night sky are not native to the Milky Way, but are the orphaned children of this titanic collision. Our home galaxy's very architecture was forged in a violent impact that predates the Earth itself. It was a turning point. We were no longer looking at individual cases of cannibalism. We were staring at the chilling possibility that the Milky Way itself is not a single pure entity. It is a composite being, a Frankenstein's monster of galactic proportions built piece by piece from the bodies of its victims. But seeing the fossilized remains, the stellar streams, and the chemically distinct populations only gives us a static snapshot of the aftermath. It's like arriving at a crime scene billions of years too late. We can see the wreckage, but we cannot see the brutal dynamic act of destruction itself. How can you possibly watch a process that takes longer than the entire history of our planet to unfold? You can't. Not in the real universe. So we had to build another one, a digital one. Inside the silicon hearts of our most powerful supercomputers, we can create virtual galaxies governed by the precise, unbreakable laws of physics. We can craft a digital Milky Way complete with its majestic spiral arms, its central bulge, its vast halo of dark matter, and its spinning disk of gas and stars. And then with a few keystrokes we can hurl a smaller, unsuspecting dwarf galaxy towards it. We can compress 1 billion years of cosmic evolution into a single week of computational time. We become gods in a box, winding the cosmic clock forward to witness the slaughter in excruciating, impossible detail. Here in this digital crucible we can finally watch the kill. The simulation begins. The dwarf galaxy, a beautiful self-contained sphere of a few billion stars, approaches the Milky Way. From a distance, gravity's pull seems gentle, a subtle, mutual attraction. But as it draws closer, the true horror of the encounter becomes apparent. The dwarf galaxy crosses a gravitational point of no return, an invisible boundary known as the Roche limit. Here, the Milky Way's gravity is no longer a uniform pull. The side of the dwarf galaxy closer to us is pulled with immensely more force than the far side. This difference, this tidal force, is the weapon. It is not a sudden impact, but a slow, relentless, and exquisitely cruel execution. The dwarf galaxy begins to stretch. First it elongates into the shape of a football. Then it is pulled thinner and thinner like cosmic taffy, its elegant spherical shape distorted into a grotesque weeping filament. The stars on its outer edges, the ones least bound by its own gravity, are the first to be lost. They are plucked away one by one at first, then in torrents, forming two magnificent but tragic tidal tails. One tail leads the doomed galaxy a vanguard of stolen stars. The other trails behind it, a ghostly wake marking its path of destruction. We can pause the simulation, fly our virtual camera through this unfolding catastrophe. We can see the tidal streams not as faint smudges in the sky, but as they truly are, breathtaking rivers of suns, millions of stars flowing in a coherent current through the void. We see the gas, the lifeblood of the dwarf galaxy, being stripped away even more violently. The Milky Way's hot halo and powerful gravitational field act like a celestial blowtorch, a process called ram pressure stripping, scouring the dwarf of its fuel for new stars. Its ability to create new life is extinguished long before its body is fully consumed. The process is a symphony of destruction playing out over hundreds of millions of years. With each pass, the dwarf swings through the Milky Way's disk, its orbit decaying as it loses energy to the larger galaxy. Each passage is a fresh torment. More stars are torn away, more gas is siphoned off. Its dense central core, a stubborn knot of stars and dark matter, holds out the longest. But eventually even this fortress is breached. The core dissolves, its remaining stars scattered and assimilated into the immense swarm of the Milky Way's own population. There is no trace left of the intruder as a distinct object. There is only the memory, the faint glowing streams of its dismembered body, and a slight, almost imperceptible thickening of the Milky Way's own structure. The cannibal has fed. It has grown larger, more massive, more powerful. And here is the most staggering part of this digital resurrection. When we run these simulations, when we program in the laws of gravity, and the estimated mass of a dwarf galaxy like Sagittarius, the patterns of destruction we see on the screen are not just abstract art. The virtual tidal streams that our supercomputers generate, the ghostly arcs of stars they predict, are a near-perfect match for the real streams we observe with telescopes like Gaia. We can replicate the Sagittarius stream in its entirety. We can model the creation of the orphan stream. We can even simulate the colossal impact of Gaia-Enceladus and watch as it violently puffs up our galaxy's disk exactly as the observational data suggests. The computer, our digital time machine, confirms our deepest suspicions. This is how it happened. This is the mechanism of our galaxy's growth. We're not just seeing the present, we're accurately reconstructing the violent past. The live cannibalism of Sagittarius is no longer an anomaly. It is the final dying act of a drama that has been playing out on a loop for 13 billion years. This realization forces us to look at our cosmic home in a completely new light. The very ground beneath your feet, the atoms in your body, are orbiting the center of a galaxy that was built. It wasn't born in its current state, it was assembled. The majestic structures we once saw as serene and eternal are in fact artifacts of violence. That vast spherical halo of ancient stars enveloping our entire galaxy, it is a graveyard. It is the blended, shredded remains of the first few hundred dwarf galaxies that the primordial Milky Way consumed in its infancy. Their stars, the oldest in the universe, now drift in a ghostly sphere, their original families long since dissolved into an indistinguishable crowd of orphans. That thick disk, the very foundation of our galaxy's inner structure, is a scar. It is the direct consequence of a massive collision that shook the young Milky Way to its core, a brutal renovation that forever changed its shape and character. Even the dense, luminous central bulge may have been fed by the remains of devoured galaxies, their cores sinking through the gravitational well to add their mass to the galactic heart, perhaps even providing fuel for the supermassive black hole that slumbers there. We don't live on a pristine island. We live in a sprawling ancient city built upon the foundations of countless raised settlements. The stars we see are not all our kin. Many are immigrants, refugees from galactic wars that were lost billions of years ago. The Milky Way is a predator, and its long history is written in the blood of its victims. Every star in every stream, every strange orbit, every chemical anomaly, is a testament to another galaxy that dared to wander too close. Our home is a monument to conquest, and this relentless process of construction and consumption has not ended. As we watch the final dissolution of Sagittarius, we are seeing just one more stone being laid upon the cosmic edifice. We are witnessing in real time the forging of our own future, but Sagittarius and even the mighty Gaia-Enceladus were relatively small. They were skirmishes, battles against lesser foes that thickened our defences and added to our mass. Now, however, as we scan our immediate cosmic vicinity, we see two new, far more formidable challenges looming on the horizon: the Magellanic Clouds. Two of the largest dwarf galaxies in our local group are now on their first fateful passage around the Milky Way. They are not like the others. They are titans, an order of magnitude more massive than the victims that came before. Their impending collision will not be a simple assimilation. It will be a war, and it will be a war that reshapes our galaxy in ways our simulations are only just beginning to comprehend. And so we know the verdict. The Sagittarius dwarf is guilty of trespassing, of wandering too close. Its sentence handed down by the immutable laws of the universe is death. But this is not a swift execution. It is a slow, methodical and chillingly beautiful dismantlement, a process of gravitational torment stretched over billions of years. To understand what is happening now in our cosmic backyard, we must first understand the weapon being used against this small galaxy. It is not an explosion, not a cataclysmic collision, in the way you might imagine. The instrument of its demise is far more subtle and infinitely more powerful. It is the relentless stretching pull of tidal forces. You feel this force every day in the ebb and flow of our own oceans. The moon pulls on the Earth, but it pulls more strongly on the side of our planet that is closer to it. This differential gravity, this slight variance in pull from one side to the other, is what stretches our world's oceans into a bulge. Now take that gentle, life-sustaining rhythm and amplify it by a factor of trillions. Replace the moon with the colossal gravitational well of the Milky Way, a vortex of 250 billion stars and a vast invisible ocean of dark matter. Replace the Earth with the fragile, loosely bound structure of a dwarf galaxy. What happens then is not a gentle pull, but a cosmic vivisection. As the Sagittarius dwarf plunges through the outskirts of our galaxy, the Milky Way's gravity seizes it in an inescapable grip. The stars and gas clouds on the near side of the dwarf are pulled with an immense irresistible force, but the stars on the far side, just a few thousand light-years further away, feel a slightly weaker pull. This is the key. This gradient, this subtle but inexorable difference in gravitational attraction across its tiny body is what condemns it. The dwarf galaxy begins to stretch. It is drawn out, elongated like a piece of cosmic taffy, pulled at both ends. The elegant spiral or spherical shape it once held distorts, contorting into a grotesque parody of its former self. The very bonds of its own gravity, the force that held it together as a coherent island universe for eons, are systematically overwhelmed. This is not a singular event, but a recurring torture. With every pass, every pericenter passage where it swings closest to the galactic core, the torment intensifies. The Milky Way's tidal shears act like a monstrous claw, raking through the dwarf, peeling away its substance layer by layer. And the first thing to be torn away is the most vital, the most precious element a galaxy possesses: its lifeblood, its vast cold reservoirs of hydrogen and helium gas. These clouds, ethereal and diffuse, are the most weakly bound to the dwarf's gravitational core. They are the easiest to steal. Imagine a celestial blowtorch aimed at a snowflake. The delicate structure of interstellar gas, the very stuff from which new stars are born, is superheated and ripped away by the tidal forces and the ram pressure of moving through the Milky Way's own tenuous halo of hot gas. This process is known with chilling accuracy as strangulation. The dwarf galaxy is being systematically starved of its ability to create. For billions of years it was a stellar nursery, a place of vibrant creation. Its great molecular clouds would collapse under their own weight, igniting in flashes of brilliant blue and white light as new generations of massive hot stars were born. It was a live, dynamic, a self-sustaining ecosystem of cosmic matter. But now its fuel lines have been severed. The gas, once a promise of future suns, is siphoned away, forming vast trailing plumes that dissipate into the void or are captured by the Milky Way itself. The star formation within the dwarf sputters, slows, and then almost entirely ceases. This is a quenching, a slow, cold death of potential. What is left behind is a skeleton crew of aging stars. The brilliant blue giants which burn through their fuel in mere millions of years are the first to die out with no new generation to replace them. The galaxy's light begins to shift its colour palette, bleeding from a vibrant blue and white to a melancholy uniform red. It becomes a red and dead galaxy, populated only by ancient long-lived red dwarf stars and the fading embers of suns like our own in their final stages. It is a ghost of its former self, a hollowed-out relic doomed to circle its destroyer, each orbit bringing it closer to final dissolution. It still looks like a galaxy for a time, but it is a facade. The creative engine at its heart has been extinguished forever. It is a museum piece, a testament to a vibrancy that has been stolen. But where does all that stolen material go? The gas is assimilated, but what of the stars? The billions upon billions of suns, each with its own potential retinue of planets, are not destroyed. They are merely relocated. They are cast out, pulled from their home by the tidal forces, and begin a new existence, not as citizens of a sovereign galaxy, but as exiles adrift in the immense void of the Milky Way's halo. These stolen stars form one of the most breathtaking and scientifically crucial structures in the cosmos stellar streams. As the dwarf galaxy is stretched and torn, its stars are spilled out into two long gossamer trails. One stream leads tracing the path the dwarf is about to take. The other trails behind, marking the road it has already travelled. These are not chaotic swarms. The laws of orbital mechanics are as elegant as they are brutal. The stars, once liberated from their home, continue to follow roughly the same orbital path as their doomed parent galaxy, creating vast coherent rivers of light flowing through the darkness. They are ghostly filaments wrapping around the Milky Way like celestial ribbons. Some are so vast they stretch across our entire night sky, yet are so faint, so sparsely populated, that they remained invisible to us for centuries. Only now, with vast automated sky surveys that can count and measure hundreds of millions of individual stars, can we perceive these phantom structures. They are the breadcrumbs of a cosmic crime scene, the evidence of a murder in progress. By mapping these streams, by studying the velocities, positions, and chemical compositions of their constituent stars, we can perform a kind of galactic archaeology. Because all the stars in a given stream were born from the same parent galaxy, they share a unique chemical fingerprint. They carry the specific ratio of heavy elements that was present in the gas clouds of their birthplace. When astronomers find a great river of stars arching over the sky, all moving in the same direction, and all sharing the same chemical DNA, they know they have found the shredded remains of an ancient victim. The Sagittarius stream, the most prominent of these structures, is the smoking gun of the very merger we are witnessing now. It is a colossal structure, a celestial highway of suns that wraps around the Milky Way multiple times, a testament to the sheer violence of the ongoing encounter. We can trace its flow, rewinding the clock, and see precisely how its parent galaxy has been dismembered over successive orbits. These fossil rivers are more than just beautiful scars. They are probes. They are our most powerful tool for mapping the unseen, because the precise path a stellar stream takes is dictated by the gravity of everything it passes. And the vast majority of that everything is completely invisible to our telescopes. This brings us to the heart of the interaction, the true puppet master pulling the strings of this entire cosmic drama: dark matter. We have spoken of the stars and the gas, the visible components that we can see and study, but they are merely the foam on the surface of a deep invisible ocean. Both the Milky Way and the Sagittarius Dwarf are not just collections of stars. They are first and foremost massive sprawling halos of dark matter, this mysterious non-luminous substance which interacts with our universe only through the force of gravity, outweighs all the normal matter, all the stars, planets, gas and dust, by a factor of more than 5 to 1. It is the true scaffolding of the cosmos. Galaxies are just the luminous decorations assembled at the very centre of these immense, spherical clouds of invisible mass. When two galaxies interact, it is not the stars that meet first. It is the halos. Long before the first star is tidally stripped, long before the first gas cloud is siphoned away, the two great dark matter halos begin to move through one another. Imagine two vast, insubstantial ghosts passing through each other. There is no physical collision in the traditional sense. Dark matter particles, whatever they may be, do not bounce off each other like billiard balls, but they do interact gravitationally. As the smaller dark matter halo of the Sagittarius dwarf ploughs through the gargantuan halo of the Milky Way, it experiences a powerful braking force. This is a process known as dynamical friction. Think of it as a kind of gravitational drag. Each dark matter particle in the dwarf's halo is gravitationally pulling on the sea of particles in the Milky Way's halo, and in return that sea pulls back. The net effect is a Waker region of slightly higher density that forms behind the moving dwarf. This overdense wake then exerts its own gravitational pull, constantly tugging backward on the dwarf, slowing it down, stealing its orbital energy. It is this invisible friction that seals the dwarf's fate. Without it, the dwarf might have been able to fly by on a wider, safer orbit. But dynamical friction ensures that its orbit decays. With every pass, it loses momentum, sinking deeper and deeper into the Milky Way's gravitational well, subjecting it to ever stronger tidal forces until it is completely obliterated. The dark matter halo is therefore both the dwarf's shield and its undoing. It is the gravitational glue that provides the bulk of the galaxy's mass, helping it resist the Milky Way's tidal forces for as long as possible. But it is also the source of the dynamical friction that guarantees its eventual demise. The stripping process we see happening to the stars and gas is happening to the dark matter as well, on an even grander scale. As the dwarf is torn apart, its own dark matter halo is unravelled and incorporated into the halo of the Milky Way. This is the true nature of galactic cannibalism. Our galaxy is not just eating stars. It is feasting on dark matter, growing its own invisible empire with the substance of its victims. This process of accretion has a profound effect on our home galaxy. It doesn't just make the Milky Way's halo more massive, it heats it up. Now, heating, in this context, does not mean temperature in the way we normally think of it. The dark matter particles do not get hotter. Instead, the term refers to an increase in their random motions, their kinetic energy. The violent plunging orbit of a captured dwarf galaxy acts like a colossal egg beater, stirring the contents of a bowl. The organized orbital energy of the dwarf is converted into the chaotic randomized energy of the individual dark matter particles within the larger halo. The halo in response puffs up. It expands, becoming less dense in the center and more extended on its periphery. It's as if the foundation of our galaxy is being shaken, resettled, and reformed by these constant impacts. Every star that is captured, every cloud of gas that is accreted, every ghost of a dark matter halo that is assimilated leaves its mark. It subtly alters the gravitational field of our entire galaxy, potentially influencing the orbits of stars far from the merger itself, perhaps even affecting the delicate spiral structure of the galactic disk we call home. This intricate dance between the seen and the unseen is what makes these mergers so fundamental to understanding the universe. The beautiful ghostly stellar streams are merely the visible traces of this far grander invisible process. They are the paint splatters that reveal the shape of the invisible sculptures of dark matter that govern the cosmos. By studying how these streams are bent and torqued as they orbit our galaxy, we can create a three-dimensional map of the Milky Way's dark matter halo with unprecedented precision. We can weigh our galaxy, trace its contours, and search for clumps and substructures within the halo itself, the undigested remains of other, even earlier victims. The Sagittarius dwarf is not the first galaxy to fall to the Milky Way, and it will not be the last. Our home is a predator built piece by piece from the ruins of countless smaller systems over 13 billion years of cosmic history. The evidence is all around us, written in these rivers of exiled stars. We are witnessing a single profound chapter in this epic story of cosmic construction. The death of one galaxy is giving rise to the continued growth and evolution of another, a transfer of matter, of energy, of legacy. The sons of Sagittarius, stripped of their home and cast into the void, are now becoming part of our own galaxy. They are the newest citizens of the Milky Way immigrants from a shattered land. But what becomes of them? Once these streams of stars are created, are they permanent fixtures of our night sky? And how does this rain of stellar debris falling from the halo affect the delicate spinning disk of the Milky Way where we reside? The consequences of this collision are not confined to the distant halo. They ripple downwards towards the galactic plane towards us. For billions of years we have witnessed the siege. We have tracked the relentless gravitational assault, the slow, agonizing surrender of a smaller cosmos to a larger one. We've seen the celestial sinews torn, the luminous arteries of stars siphoned away into the void, a battle fought in the silent, indifferent theatre of deep space. But every war, no matter how protracted, eventually reaches its end. This is the story of the aftermath, the final act in the life of a galaxy. It is a story not of an ending, but of a profound and violent transfiguration. What happens when the heart of the dwarf galaxy, its once dense and defiant core, finally succumbs? It crosses a cosmic event horizon, not of a black hole, but of the Milky Way's overwhelming tidal force. The final coherent structure is breached. The gravitational bonds that held its stellar family together for eons are irrevocably snapped. Imagine a crystalline sculpture, impossibly intricate, struck by a final resonant frequency. It doesn't just break, it disintegrates into a cloud of shimmering dust. This is the fate of the dwarf's core. Its stars, once locked in orderly, predictable orbits around a common centre, are now cast adrift like prisoners freed into a new, unimaginably vast and chaotic landscape. This final stage is known by a deceptively gentle name phase, mixing. The reality is anything but. It is a process of complete and utter disorientation. A star that once wheeled in a slow majestic arc within its home galaxy is now violently flung onto a new eccentric path through the Milky Way. Its orbital trajectory is stretched, twisted, and folded back on itself by the complex churning gravitational field of our galaxy. Over hundreds of millions of years, this process repeats over and over again for every single star. Their once shared orbit, the last vestige of their common origin, is scrambled beyond recognition. They are put through a cosmic blender, their paths randomized until statistically they become indistinguishable from the background stars of the halo. The tidy, coherent stream of stars we saw earlier, that beautiful, tragic ribbon of light, blurs at its edges. It widens, thins, and eventually dissolves entirely, its light spread so thinly across such a vast volume of space that it simply vanishes into the stellar foreground. The galaxy as a distinct entity has ceased to exist. It is a ghost, its form dissipated, its presence seemingly erased from the cosmic record forever. Or is it? This is where the story pivots from destruction to detection, from a celestial tragedy to one of the most profound detective stories in modern science, the field of galactic archaeology. For even after the gravitational blender has done its work, even after the last visible stream has faded into black, the consumed galaxy leaves behind indelible clues. It leaves behind its dead, and if you know how to listen, you find that these stellar corpses still whisper the secrets of their origin. You see, a galaxy is more than just a collection of stars held together by gravity. It is a chemical system, a unique cosmic ecosystem with its own history of creation. Stars are alchemical forges, cooking lighter elements into heavier ones. Each successive generation of stars in a galaxy enriches the interstellar gas from which the next generation will be born. A small isolated dwarf galaxy with its slow sporadic history of star formation develops a very different chemical personality than a vast bustling metropolis like the Milky Way. Its stars will have a distinct accent, a unique ratio of elements like iron, magnesium, and oxygen. This is its DNA, and this chemical signature is locked into the atmosphere of a star at its birth. It is a permanent birth certificate, a chemical passport that it carries for its entire multi-billion-year life. So while we can no longer see the shape of the vanquished galaxy, we can hunt for its scattered children by analysing the light from millions, even billions of individual stars. Using powerful spectrographs, astronomers split the light from a distant star into its constituent colours, a rainbow crossed by dark lines. Each line represents an element, its thickness, a measure of its abundance. It is a painstaking forensic examination of our own galactic halo. For thousands of hours on mountaintops across the world, we stare deep into the Milky Way, sifting through the light of countless suns. And every so often we find one that doesn't belong. A star whose chemical passport is stamped with a foreign seal. A star whose light sings a different chemical song, a faint lonely ballad of a home that no longer exists. When we find one such star, it's a tantalizing clue. When we find a group of them moving with a subtly similar velocity, a shared memory of their old orbit. We know we have found it. We have found the phantom limb of a consumed galaxy. We are looking at the remnants of Gaia-Enceladus, the sausage galaxy, a massive dwarf system devoured by our Milky Way 10 billion years ago. Its body is gone, but its constituent stars, tens of millions of them, still swim through our halo, their alien chemistry a permanent testament to a murder that built our home. We are tracing the ghosts of Sagittarius, of Canis Major, of countless others, their names now just entries in astronomical catalogues. This is the legacy written in starlight. The Milky Way is a graveyard, and our telescopes are the tools we use to read the epitaphs. But the story of this cosmic cannibalism is not solely one of ghosts and relics. The act of consumption is not a sterile, silent absorption. It is a dynamic, violent event that profoundly and creatively impacts the consumer. As the dwarf galaxy is torn apart, it doesn't just bleed stars. It hemorrhages vast clouds of hydrogen and helium gas, the raw fuel for creation. This material, once destined to form stars in a different galaxy, is now dumped unceremoniously into the Milky Way's halo. Gravity does not let it linger there for long. It rains down onto the galactic disk, a celestial downpour of primordial fuel that can last for millions of years. When these clouds, travelling at hundreds of kilometres per second, slam into the dense gas-rich spiral arms of our own galaxy, the consequences are spectacular. The collision generates immense shock waves, cosmic sonic booms that ripple through the Milky Way's interstellar medium. These shock waves act like a giant piston compressing the resident gas clouds, far beyond the critical point needed for them to collapse under their own gravity. The merger acts as a celestial defibrillator, shocking dormant regions of our galaxy into a sudden convulsive frenzy of creation. Entire stellar nurseries light years across are ignited all at once. What was a quiet, dark nebula is transformed into a blazing cauldron of light as thousands of new suns switch on in a geological blink of an eye. We call these events starbursts, and they are among the most luminous and energetic phenomena in the universe. From the ashes of a dead galaxy, a brilliant new generation of stars is born. These are the Phoenix stars. They are massive, ferociously hot, and blaze with a brilliant blue-white light. They burn through their nuclear fuel in a mere fraction of the sun's lifespan, living fast and dying young. When they die, they explode as supernovae, magnificent displays of self-destruction that seed the galaxy with even more heavy elements, the very building blocks of planets and of life. So you see the paradox. The act of galactic destruction is simultaneously one of the galaxy's most potent engines of renewal and growth. The Milky Way is not just a predator, it is a cosmic recycler. It takes the raw materials of its victims and uses them to build and enrich itself. The beautiful glowing nebulae you see in stunning astrophotographs, the vibrant stellar nurseries where new solar systems are forming right now, many of them owe their existence to these ancient violent collisions. The very fabric of our galactic disk is being constantly replenished and reinvigorated by the steady rain of material from cannibalized companions. Without this ongoing process, our galaxy's star formation would have slowed, perhaps even stopped billions of years ago. The Milky Way would have become a quiet, aging reddish galaxy, its best days behind it. Instead, it remains brilliantly alive, a dynamic and evolving system, its vitality continuously purchased with the lives of smaller galaxies. This infusion of new material does more than just trigger fleeting starbursts. It fundamentally alters the grand chemical blueprint of the Milky Way itself. Our galaxy, like most large spirals, has a distinct metallicity gradient. Stars near the dense ancient galactic center are rich in heavy elements, the product of billions of years and countless generations of stellar evolution. As you move outward toward the galactic fringe, the stars become more metal-poor, more pristine, composed mostly of the hydrogen and helium from which the universe was born. This gradient tells a story of how our galaxy was built from the inside out. But the mergers disrupt this orderly narrative. When a dwarf galaxy with its own unique chemical history is consumed, its contents are not distributed evenly. Its stars and gas are scattered throughout the halo and outer disk, injecting a different chemical recipe into regions far from the galactic core. A metal-rich dwarf, for instance, can seed the Milky Way's metal-poor outskirts with heavy elements enriching the interstellar medium in places that would otherwise have remained barren. This has profound implications. It means that future generations of stars forming in the galactic suburbs will have a richer palette of elements to draw from. Planets forming in these enriched zones are more likely to be rocky like Earth, rather than just gas giants. The raw ingredients for life forged in the hearts of stars and delivered by these galactic collisions are spread more widely, increasing the potential habitable real estate across our entire galaxy. Each act of cannibalism is an act of chemical redistribution. It is an alchemical inheritance where the victim bequeaths its entire stellar and gaseous fortune to its conqueror, ensuring the victor's continued prosperity and complexity. The Milky Way we inhabit today is a composite entity, a mosaic. Its halo is haunted by the ghosts of its victims. Its disk is ablaze with the fire of their recycled fuel. Its very chemical composition is a layered history of countless acquisitions, a story of growth through assimilation. What appears from a distance as a serene and majestic spiral and island universe in the cosmic dark is, upon closer inspection, a battlefield, a graveyard, and a celestial nursery all at once. The violence is inseparable from the beauty. The destruction is the very mechanism of creation. This ongoing, brutal yet fertile process has shaped every aspect of our galactic home, from the orbits of the oldest stars to the chemical makeup of the very planet beneath our feet. It is the engine that has driven the Milky Way's evolution for over 12 billion years. And in understanding this cycle, we understand that nothing in the cosmos is ever truly lost. It is merely transformed, broken down, and reassembled into something new, something grander, something more complex. The energy, the matter, the very identity of a fallen galaxy lives on, encoded in the light of alien stars and the genesis of native suns. It is a legacy of violence, but it is also undeniably a legacy of life. This realization forces us to look at our own place in the universe with new eyes. We are the children of this process. Our solar system was born from a cloud of gas and dust, enriched by supernovae from countless prior stellar generations whose birth rates were fueled by these galactic mergers. The iron in our blood, the calcium in our bones, the oxygen. We breathe these elements were forged in stars, and the distribution of those stars, the very architecture of our galaxy, is the product of this endless cannibalism. We are in a very real sense the beneficiaries of this cosmic violence. This intricate dance of gravity and chemistry, of death and renewal, is not something that happened only in the distant past. It is happening now. The Sagittarius Dwarf is making its final screaming pass through our disk. The Magellanic Clouds, our largest satellite galaxies, are on a trajectory that will see them absorbed into the Milky Way in the cosmically near future. The process is not over. Our galaxy is still growing, still feeding, still evolving. And as we look out beyond our own galactic shores, we see that this is the fundamental rule of the cosmos. Galaxies everywhere are locked in this same gravitational struggle. But it also forces upon us a humbling and perhaps unsettling final question. If this is the law of the universe that the large always consume the small, then what is the ultimate fate of a grand galaxy like our own? Is the Milky Way, the triumphant conqueror of so many smaller systems itself, destined to play the role of the victim in an even larger cosmic drama? Because out there in the darkness, something is coming for us. And so the story of Sagittarius, the ghost galaxy haunting our own reaches, its final inevitable chapter. We have followed its celestial death throes, tracing the ephemeral ribbons of its being as they are woven into the grand tapestry of the Milky Way. We have learned to read the sky not as a static portrait but as a living chronicle of a vast and violent history and ongoing saga of conquest and assimilation. This journey has taken us from the quiet confusion of early astronomers who saw these faint streams as mere curiosities to a profound and unsettling revelation. We have unmasked our galaxy for what it truly is, a cannibal built from the recycled starlight and shattered cores of countless victims over billions of years. We began this exploration seeking to understand a strange pattern of stars, and in the end we have uncovered the fundamental secret to our own cosmic existence. The vision of the Milky Way as a serene, isolated island of light, a majestic pinwheel turning gracefully in the void has been irrevocably shattered. That was a portrait born of distance, of seeing only the present moment. Now, with the new eyes granted to us by missions like Gaia, which measure the precise choreography of billions of stars, we can perceive time itself. We can rewind the celestial clock watching as primordial clouds of gas collapse to form the first stellar nurseries, and fast forward to witness the inexorable pull of gravity drawing smaller galaxies into a fatal embrace. What we once saw as a city of stars is now revealed to be a sprawling ancient empire, one that achieved its grandeur not through gentle growth, but through relentless consumption. Every star you see, every constellation that wheels across your night sky is part of this story. Some are native-born citizens of the old Milky Way, while countless others are immigrants, refugees, or the orphaned children of galaxies long since devoured. Their chemical signatures, their peculiar orbits, their very existence within our spiral arms are the telltale clues, the cosmic DNA evidence of a past that was anything but tranquil. This realization transforms our relationship with the cosmos. The dark matter halo that invisibly envelops our galaxy is no longer just a static scaffold. It is a gravitational web, a sticky and inescapable trap for any dwarf galaxy that wanders too close. The beautiful looping stellar streams are not decorations. They are scars, the luminous wounds of a battle that has raged for eons. They are the final broadcast of a dying civilization, a message written in starlight that travels for hundreds of thousands of years to tell us we were here. We fought. We lost. By deciphering these messages, we have become galactic archaeologists, piecing together the history of our home from the bones of the vanquished. We have learned that the very structure of the Milky Way, from the chemical enrichment of its disk to the puffed-up, chaotic nature of its halo, is a direct consequence of this cosmic diet. Our galaxy is not a pristine creation. It is a composite being, a Frankenstein's monster of galactic parts stitched together by the unforgiving thread of gravity. And in understanding this, we have stumbled upon a universal truth. This is how the universe builds. This is how complexity arises from chaos. Galaxies are not born as giants. They achieve greatness by standing on the shoulders of the galaxies they have consumed. This new dynamic understanding forces us to look forward, to lift our gaze from the ghosts of the past and confront the titan looming in our future. For the saga of galactic cannibalism is far from over. Our Milky Way, for all its predatory prowess, is not the unchallenged sovereign of our local cosmic neighbourhood. There is another and even grander empire of stars hurtling towards us through the intergalactic darkness, the Andromeda Galaxy. It is our cosmic twin, our gravitational rival, and our ultimate destiny. Right now, it hangs in our autumn sky as a faint, fuzzy smudge of light visible to the naked eye if you know just where to look. But that smudge is a deception. It is a portal to a future so dramatic, it dwarfs every collision the Milky Way has ever endured. Andromeda is larger, more massive, and it is approaching us at a staggering speed of over 100 kilometers every single second. That's fast enough to cross the continental United States in less than a minute. There is no ambiguity in this prophecy. It is not a matter of if, but when. The relentless laws of physics have already signed the death warrant for both galaxies as we know them. In approximately 4.5 billion years, the slow, inexorable pull of gravity will bring this cosmic dance to its spectacular crescendo. Our study of Sagittarius and the other dwarf galaxies is not merely an academic exercise. It has been our training ground. It is the crucial Rosetta Stone that allows us to translate the coming chaos. We have seen on a smaller scale how these mergers unfold. We have witnessed the first tentative touches of tidal stripping, the brutal gravitational stretching, the slow unravelling of a galaxy structure. Now we can apply those lessons to the main event, the title fight for the local group. The first signs of the collision will be subtle, appearing in the outermost gossamer-thin halos of gas and dark matter that surround both galaxies. These vast invisible spheres will be the first to make contact, brushing against one another, compressing and sending gravitational ripples cascading through both systems. This initial touch billions of years from now will be the cosmic handshake that seals their fate. Then the main disks will begin to interact. Imagine a night sky 4 billion years from now, from a world not so different from our own. Andromeda would no longer be a faint smudge. It would be a breathtaking, terrifying spectacle, a colossal spiral of light filling a huge portion of the heavens, its intricate dust lanes and brilliant star clusters visible in stunning detail. As the galaxies pass through each other for the first time, it will be a moment of sublime violence. Contrary to what you might imagine, individual stars will almost certainly not collide. The space between them is simply too vast. Our Sun and its planets will likely survive the initial pass unscathed, but the gravitational havoc will be unimaginable. Entire constellations will be warped and dissolved. Stars and solar systems will be torn from their stately orbits and flung into the intergalactic void, destined to wander alone for eternity. Others will be thrown inwards towards the churning, chaotic heart of the merger. This gravitational disruption will act like a colossal shockwave ploughing through the vast clouds of interstellar gas and dust that permeate both galaxies. These nebulae, the cold, quiet nurseries where stars are born, will be compressed and ignited. The result will be a firestorm of star formation, a galaxy-wide baby boom of staggering proportions. Across the merging galaxies, trillions upon trillions of new brilliant blue stars will flare into existence, illuminating the mangled spiral arms and tidal tails with an ethereal incandescent glow. The sky, as seen from any surviving planet, would be ablaze with the light of new suns and the vibrant colours of ionized gas clouds, a celestial canvas painted by the collision. This period of frantic starbirth, known as a starburst, will be the creative fever that accompanies the destructive merger. It will forge new elements, new solar systems, and perhaps new possibilities for life, all from the wreckage of the old order. After this first violent passage, the two galaxies, gravitationally bound, will pull away from each other, their forms horrifically distorted. They will be trailed by immense tidal tails of stars and gas hundreds of thousands of light years long, like cosmic streamers flung across the void. But they cannot escape. Gravity will act like a titanic anchor, slowing their retreat, halting them, and then inevitably pulling them back in for a second and then a third encounter. Each pass will bleed away more energy, drawing them closer and closer. The two supermassive black holes lurking at the centres of each galaxy, Sagittarius A and its Andromeda counterpart, will begin a deadly orbital dance of their own. They will circle each other closer and closer, shedding tremendous amounts of energy, as gravitational waves ripples in the fabric of space-time itself. This cosmic ballet will continue for millions of years, until finally they too will merge in a cataclysmic event of almost unimaginable power, an explosion of gravitational radiation that will shake the very foundations of the local universe. When the chaos finally subsides after hundreds of millions of years of turmoil, the Milky Way and Andromeda will be gone. In their place will be something new, something magnificent. A single colossal galaxy will dominate the local group. The beautiful spiral structures will have been completely erased, smeared out by the gravitational chaos into a vast roundish ball of stars. This new entity, which some astronomers have already nicknamed Milkomeda, will be a giant elliptical galaxy glowing with the soft golden light of its trillions of aging stars, punctuated by the brilliant blue flashes of the last generation born in the merger's firestorm. The Sun, should it, and the Earth survive, will find itself in a very different home. Our familiar constellations will be gone, replaced by a dense uniform sea of stars. And our descendants, if they exist, will look up at a night sky devoid of the graceful, inspiring arc of the Milky Way, living instead within a celestial megalopolis, the quiet, mature remnant of a violent, passionate youth. This is our future. Not an ending, but a transformation. A cosmic rebirth forged in the crucible of a galactic collision. This grand prophecy is not unique to us. When we turn our most powerful telescopes to the distant universe, we see that this story has played out time and time again. We see galaxies in every stage of this process, some just beginning their gravitational dance, others locked in a chaotic embrace, and still others settling into their new unified forms. We see the antennae galaxies with their spectacular tidal tails arcing through space. We see the mice galaxies, two spirals streaming past each other, trailing stars like cosmic confetti. These are not just beautiful astronomical images, they are snapshots from the Universal Family album. They show us our past and they show us our future. Galactic cannibalism is not an anomaly, it is the rule. It is the engine of cosmic evolution, the primary mechanism by which the universe builds its most majestic structures. Without these mergers, the cosmos would be a far simpler, less interesting place, populated only by small anemic galaxies. It is through this process of destruction and consumption that richness and complexity emerge, and so we are left with a final profound realization. The universe is not a quiet, static place. It is a dynamic, living, and often violent ecosystem. It is a place of constant change, of relentless creation and destruction, where even the grandest structures are subject to the inexorable forces of gravity and time. When you look up at the night sky now, you're not seeing a collection of distant, disconnected points of light. You are looking at the participants and the evidence of a drama on a scale that defies human comprehension. You are seeing the ghosts of galaxies past and the heralds of galaxies yet to come. The starlight that reaches your eyes has travelled across a battlefield, carrying with it the story of that cosmic struggle. We are inextricably part of this story. The iron in your blood, the calcium in your bones, all the heavy elements that make up our world and our bodies were forged in the hearts of stars. And those stars in turn were brought together by this very process of galactic merger and acquisition. We are in the most literal sense the children of galactic cannibalism. We are built from the debris of cosmic collisions. We exist because the universe is not gentle. We exist because galaxies eat other galaxies, recycling their matter into new stars, new planets, and new possibilities. The process is violent, but its outcome is creation. It is a cycle of cosmic death and rebirth, and we are its living, breathing, thinking legacy. The sky above is not a ceiling. It is an ocean of time, and in its shimmering depths we can finally read our own epic, ongoing origin story.